So how can we represent a doubly linked list programmatically inside our computer? So the process is almost similar to the singly linked list or the normal linked list that you have learned before. Here also we are going to utilize two different classes, that is vertex and the doubly linked list class. So the first class, which is vertex, that represents each element or each node or each single vertex of the list, like these rectangles, what you have done in case of singly linked list also. And then there is a second class called the doubly linked list, which basically make use of some special type of vertexes like the head vertex and tail vertex to implement many different functionalities of linked list. So the structure is same. Two classes, one to represent each vertex separately and another class to implement all the functionalities. Now the only difference is, as you can see, the existence of this previous link, which is another self-referential object of same type class vertex to point or to the previous node of any previous node or previous vertex of any current node, like these blue lines, blue links here in the figure. So everything else remains same as the linked list. If you want to access the node with node represented with 1, you can access it with head.next, or any operation related to the next link remains same as your singly linked list or the normal linked list. The question that I would like to ask in here is, how can we access the vertex at index 2, that is the vertex in here or in here? Well, utilizing a singly linked list, you can use it just by using head dot next dot next, something like this. So it will start from head, then it will move to next, then it will move to next. So this way you can access the element at access the element at vertex 2. Now here's, because of the existence of this previous, these blue links, you can easily access it using this tail dot previous. So tail is pointing to the last node, and just by utilizing this previous link over here, these blue lines, you can easily access the vertex 2 or vertex at index 2. So that's one use of previous, how you can move towards the, how you can access the previous node. The other question is, what is there next to tail and also previous of head? Now in both the cases, you can think of that there is null in case of the end of tail or in case of previous of head. In both the cases, there is actually null value in all the linked list, in here as well as in here. So by utilizing all these previous and the existence of this null and all the head, tail, vertex and the next previous link, we can implement different functionalities of doubly linked list that will go inside this doubly linked list class, and we are going to describe all the functionalities in the following few videos.